Hello, my name is William Atul, and I'm going to speak with you about the Neo4j database. Graph theory was originally created when Leon Euler proposed a problem known as the Seven Bridges of Königsberg, where he challenged people to find a route through the city utilizing the seven bridges without repeating their route. So graphs are widely used in mathematics and computer science, where you have an object that is referred to as a node or vertex that is connected to another node or vertex between some relationship, and this relationship is referred to as an edge. And the relationships can have many directions, where they can be one-to-many, one-to-one, they can be unidirectional or bidirectional. Here we have an example of a two-node graph connected by a unidirectional relationship. The nodes have a property called message to them on both sides, and the relationship is a type knows relationship, and it also has a property along with it called method. And graphs are widely used within Facebook, by Google in sociology and ancestry researches. And then there's even other obscure type of utilization of graphs by comic book companies and by Hollywood series. Why do we need a graph database? Well, the problem is that when you are traversing a graph, which is the equivalent of a series of joins in the relational database world, you can see that the performance of these particular joins start to degrade using a relational database in comparison to a database that is designed with graph data types in mind. And so this is a friends, find a list of friends type experiment that was run by people who wrote the Neo4j in Action book. And you can see that the results there, where MySQL starts to roll off after about 4 joins. So, like I said, it's important to have a database that supports graph databases, but Neo4j in particular is a particularly good one. It's open source, it's very well documented at the website, and there's lots of resources outside of that, so there's a good support community. It's NoSQL in nature, where you can, you don't necessarily have to have a rigid schema. You can set properties kind of on the fly, if you will, for nodes and relationships. It also has its own robust query language called Cypher. There's lots of support for various popular languages, and there's even a RESTful API for it. It installs on Linux and Windows, and there's very good performance on either platform. So for my example, we install it on Debian Linux on top of our VMware workstation. So what we'll need to do during the install is we'll need to go ahead and add the Neo4j admin user to the sudoers file. You'll need to install Java. And then here's how to configure Java for Debian. If you're not using Debian for this example, you need to go ahead and follow the particular instructions for your distribution. And you can check to see what version you're running by running the Java space -version command and see the output. If you want to view the code examples on your VM, you will also need to install Eclipse. And then finally, we can go ahead and install Neo4j. It's pretty simple. You'll simply just download the tarball, and then you'll untar it into a directory. So in this case, into opt. And then you're ready to actually start the database up in its default configuration, just by simply issuing the Neo4j space start command that's found in the binary directory there. And then you'll see output for the server startup. When you get the OK, you'll also get a URL for the web admin interface, and you can test that by launching a web browser in the VM and pointing it to localhost :744. Okay, so we can go ahead and do a simple node implementation. A simple graph implementation using two nodes with a single relationship between them. You'll notice that on either side of this graph representation, we have a node. The node has an ID, it has a node property, and then there's a assigned value to that property. And then in the middle there, you have your edge, and it is the edges are typed, meaning you can have multiple types like no's and likes and so on and so forth. Those relationships can also have properties, and in this case, you can see that it has a message property. Here we can see the code snippet to create our initial database. The one thing that you need to pay attention to is every connection to Neo4j is handled by this transaction object. So the operations that you plan to do need to pass through this transaction object, and you basically then, after you do your operations, you close out the transaction with the success. Here under the read network method, we can then go ahead and do a simple traversal of the network, accessing each method for each node and relationship, and then outputting that. Okay, so we can go ahead and create a social network called Candy, where the topic is candy bars. We're going to create that programmatically to show which users like which particular candy bars. We'll create a simple recommender system, and we'll use Java to create the main components for this. And then we can show the output in Eclipse. And then we also will use the Neo4j Cypher query language to do an ad hoc query of the social network. So here's a description of the social network itself. You can see here that we have 3 nodes. Each node has something called a label to it, and this allows us to actually add a data type to a node. You can see here that the relationships is friend of has been established. And you can also see the candies down below, and they also have a relationship called likes, and that relationship has a property called noms, where the user can go ahead and score their rating for a particular candy bar. Okay, so we create this using 2 main components, which will basically be creating the user nodes and establishing the relationship between those nodes, and then create the candy nodes, and then establishing the relationship between the users and the candy bars. Here's the main data snippet. It's very similar to the hello world snippet. However, we're adding in this label data type because we're going to use that to query on. And so this is a nice thing to have if you have nodes of different data types as we do, which is users and candy bars or candies. And so here we see something similar where we're creating nodes, we add our candy labels in, and then we go ahead and we create those relationships of the data type like, or the relationship type like, and then we add noms to score it. Okay, then our next thing is we go ahead and traverse the social network programmatically. This is also known as graph mining, where we take some output and we put it somewhere in either our analytics system or our recommender system. And so what we will do is we will go ahead and go through, we will iterate through an object where we get all of the relationships for each user, and then we iterate through the object to find the ones where they equal the type like, and then we output those in this particular for loop and show which candy each user likes. We can build a simple recommender system based on candy bars that have been liked by a user's friends, but the user itself has not had or liked. And here you can see the code for that. We again create a series of hash set objects, and we populate those for first for the friends and the candies that the friends like. We then create another hash set for the candies that the users like. We get rid of the candies that the user has tasted from friends already, and then we iterate through that hash set, and we basically output candies where they haven't the user hasn't tasted. Neo4j has a query language called Cypher. In order to use this from the web admin console, we need to make a change to the server properties file in the conf directory, and we basically need to point it to our database that we created under our Candy D code, and then save the changes to the file. And there, what happens is from the command prompt, we start the server back up, and from the command prompt, or we launch the user admin console in the browser. We input the following query, which basically flows similar to how you would traverse a graph network in logic. And so basically we're saying start at user node 0, and we're looking for matches of users that have liked a particular candy. So we're going to say, okay, user 0, which candy do you like? And you see down here at the bottom it returned a single node with in a node ID of 3, and the name property for that candy is Snickers. And we can review that in our diagram, and we can see indeed node 0, Roger here, does like Snickers. Okay, so all of the code for doing this has been included in the submission, and you're more than welcome to follow along. Thank you.